Okay. So I hope you guys already remember in yesterday class I told you today I am going to teach you first of all the packet flow in the different subnet, right? Everyone.
Yes.
Okay. So guys, in yesterday class we discussed the packet flow in the shame subnet. So this was the topology, right? In yesterday class we discussed here. Now in today class we have this one. Okay. So here guys we have a router. We have a router. Okay. And we know every interface of a router will be in the different network. So on this router, how many interfaces are there? Two interfaces, gig 0 by 0 and gig 0 by 1. So on gig 0 by 0, we configure 192.168.1.0 this network. Okay. And on this interface, we configure 10th network. It means this is the different network and this is the different network. And this is the responsibility of router to make communication possible from this network to this network and this network to this network. Clear everyone? I hope you guys understand till now.
Yes.
So I just elaborate the topology. So I have PC number 5. On PC number 5, I configure 192.168.1.1. And on this interface, I configure 192.168.1.10. Here I configure 10.1 and here I configure 10.0. Clear? So it means this is our 192.168.1.0 network and this is our 10th network. Okay. Now the question is, who can tell me the answer? I already told you these things many times. What is the default gateway for PC number 5? What is the default gateway for 10? No. What is the default gateway for PC number 5? What is default gateway? Who can define me?
192.168.1.10.
Default gateway is the exit point of the network. Yes or no, everyone? It means
Yes.
if PC number 5 wants to exit from 192.168.1.0, then what is the exit point? Guys, this is
192.168.1.10.
point. So 192.168.1.0, that is the default gateway for PC number 5. Clear? I hope you guys understand.
Yes.
Now, what is the default gateway for PC number 6?
10.0.0.10.
Yes. So now configure these things. Our default gateway will be guys 192 dot. I am writing 10. I hope you guys will understand right now. Then default gateway will be guys 10 dot 10.10. So this is the default gateway for this PC and this is the default gateway for this PC. Clear, everyone?
Yes.
Okay. Now come on this PC. I hope you guys already aware how to configure the IP address.
Yes.
192.168.1.1 and here by default subnet mask is this one. Default gateway guys 192.168.1.10. This will be the default gateway. Now come on this PC. What is the IP address? 10.0.0. Oh. Okay, just tell me one thing. Can I write like this?
No, sir.
No? I can. And we can. Yes, guys, we can write. There is no problem. Okay. Now, what is the default gateway? 10.0.0.10. This is the default gateway. I hope it's clear to all of you. Everyone. Clear?
Yes.
Okay. On PC number 5 and on PC number 6, we configure the IP address. We are not going to configure anything on the switch. Okay. Now come on the router. I hope my screen is visible to all of you. It's
Yes,
fine
sir.
now. Okay. Are you guys able to see my router CLI?
Yes, sir. Yes.
Okay. So first interface is Guys, what is the host name of this router? Router. If you want, you guys can change the host name. This is called host name. This is called host name. Okay, na? See what this is the command. Host name. Let's suppose I am writing Shubham. See now, what is the host name? Clear? Everyone, tell me. Understand now?
Yes. Understand.
Now, interface gig 0 by 0. IP address. What is the IP address? 192.168.1.10.
Ten.
Subnet mask 255.255.255.0.
Zero.
And by default, all the interface of a router is in shutdown state. So you have to write no shutdown.
Shutdown.
You understand now, everyone? Yes or no? Yes?
Sir.
Yes, sir.
Now interface gig 0 by 1. IP address 10.0.0.10 255.0.0.0 and no shutdown. Clear? I hope you guys understand till now.
Yes, sir.
Okay. I told you router make which table, guys? Routing table. Yes or no? Everyone. What is the
Yes,
command?
sir.
Show IP route. This is the command to check the routing table of the router. This is the command to check the routing table of router. Getting my point, everyone? Tell me. Understand?
Yes, sir.
These
Yes.
are the code. These are the code. So it will help you to understand. Let's suppose this is C. Now you guys will think what is the meaning of C here. So here you guys will get C means connected. C na? C means what? Connected. Getting my point, everyone? So this is the code. It will help you to understand what is the meaning of these things. Are they clear, everyone? Yes or no? Tell me. Clear
Yes,
now?
sir.
Okay. So in this routing table, see guys, 10.0.0.0 /8. It means this is the network ID. This is the network ID. Yes, na? I hope you guys already aware about the subnetting, right? So this is
Yes.
called network ID. So we cannot assign this one to any device. Yes or no? Yes, na? We are
Yes, sir.
assigning a particular IP address. A particular IP address is /32. So see na, this is 10.0.0.10. So this is the particular IP address. Getting my point? And this IP address is directly connected to which interface? Gig 0 by 1. So gig 0 by 1, 10.10 we configured. Yes or no, everyone? Clear?
Yes, sir.
Tell me. Clear now?
Yes, sir.
Similarly here 192.168.1.0/24. It means this is again the what? Network ID. This is again what? Network ID. Are you getting my point? And this network ID is connected with which interface? Gig 0 by 0. Clear? I hope you guys understand. This is called routing table. And what is the command? Show IP route. They tell me. Understand? And I told you router make one more table, that is the ARP table. Right now, everyone. So ARP. So when I write the so ARP, see. So ARP, this is the command to check the ARP table. Are you understand? So see now, what is this? This is the address. In address, what is the thing? 10.10 and 192.168.1.10. It means on this router here you configure 192.168.1.10 and here you configure 10.10. Yes or no? Everyone, tell me. Understand?
Yes, sir.
And this is called
Yes.
hardware address. It means this is the MAC address of every interface. This is the MAC address of every interface. Are you getting my point, everyone? And this is what? This is called interface. Understand? Tell me.
Yes, sir.
So this is called the ARP table. In some time, so IP ARP. If you write this one now, this is also the same command. Either you can write this one or either you can write this one. Both are same. Clear? Everyone.
Yes, sir.
Now let's just start key how actually packet will flow. ARP, ICMP and rest are now I am pinging guys from PC number 5 to PC number 6. Okay. So here I am writing ping. What is the IP address? 10.1, right? 10.0.0.1. Anyone? Any doubt? It's clear now? Tell me. Everyone. It's clear?
Yes, sir.
Yes.
Okay. So on PC number 5, I write 10.0.0.1. So PC number 5, first of all, generate which packet, guys? ICMP packet. Whenever you write the ping command, ping is what? Ping is utility. I told you in yesterday class. Ping is
Yes.
utility. And ping use which protocol? ICMP protocol. Right? So see now, this is the ICMP packet. Clear na? And for every protocol, there will be a header. So see now, what is this? In ICMP header, this is the type field, okay? Sequence number. So this is called the ICMP header. After ICMP header, what is the header? Layer 2, sorry, layer 3. Layer 3 at layer number 3. Which type of header is this? IP header, IPv4 header. Yes or no? Everyone,
Yes.
are you tell me? Yes, na? Guys, why you guys are so silent? Okay. I want response from everyone. Please don't silent. See, this is called which header, guys? IPv4 header, right? Everyone. So in IPv4 header, this is the version. This is IPv4, okay? And this is the TTL value, okay? Now, what is this? This checksum source IP. Source IP is 192.168.1.1, right? Because PC number 5 IP address is 192.168.1.1. Guys, why here 169? Is there any problem? Let me check. What IP we configure, guys? Here, sorry. We configure what? 192.169. Okay. Let me reconfigure it, guys. Everything we need to change. And on router, what we configure, guys? So, what is the command to check the which type of IP address we configure on the router? What is the command? So, IP interface brief. What is the command? So, IP interface brief. This is the command to check which type of IP address you configured. See now, I configure here 168.0, right? And here we configure 169. Okay, now everyone, are you tell me? So, what we need to do? Why we are deleting it? IPconf 192.168.1.1. Clear na?
Yes.
We So what is the command to check the interface IP address, guys? Command is 192.168.1. Tell me 192.168. Sorry, what is the command? So IP interface brief, right now.
Great.
Now here, come here, and I am writing now ping 10.0.0.1. So when I write ping 10.0.0.1, how many packets are there? ICMP packet and tell me ARP packet, right? I am opening this one. See, what is this? ICMP header is there? Yes or no? Everyone tell me. Tell me
Yes.
yes or no. Yes, na? So what is the version? Version is
Four.
4. Version is 4. It means this is the IPv4. This is the TTL value. Okay, na? This is the checksum. What is the source IP address? 192.168.1.1. It means this is the source IP address. Destination IP address is 10.0.0.1. It means this is the IP address of PC number 6, because you already write na command ping 10.0.0.1. Yes or no? So it means this is your destination IP address. Yes or no, everyone? Right? So this is the destination IP address. Fine. And this is the ICMP header. And guys, this one generate at layer number 3. This one generate at layer number 3. Layer number 3 hand over to layer number 2. And at layer number 2, which type of header is this? Ethernet header. Yes or no, everyone?
Yes.
Tell me. Yes, na? At layer number 2, which type of header? Ethernet header. And in Ethernet header, what are the content? Source MAC and destination MAC. Yes or no, everyone?
Yes.
Yes. In source MAC will be PC number 5 MAC address. Yes or no? Tell me. PC 5 MAC address and destination MAC will be
MAC address.
PC 6 MAC address, right? Everyone.
Yes, it will be inside packet.
Everyone, tell me yes or no.
First packet, there is no MAC address.
Please tell me one thing. Why there will be a
0,
MAC
0, 0.
destination MAC address in destination MAC PC number 6 MAC address? For example, PC number 5 don't know what is the MAC address of PC number 6. It means it generate which packet? ARP packet. Yes or no? Tell me. Yes. This ARP packet will reach on the switch. What switch will do? This is the broadcast packet. So switch will broadcast it. Packet will reach on router. Tell me. Right? An ARP packet is the broadcast packet. Is router forward this packet towards this network?
No.
No, never. So that's the reason I already told you many times. ARP packet never cross from one network to another network. Please keep in mind this one. ARP packet never go one network to another network. Clear na? So it means this router never forward this ARP packet from this network to this network. Then how your ARP packet will find the destination MAC address as a PC number 6? It is not possible. Getting my point, everyone? Understand? Tell me yes or no at least. Yes. If your ARP packet not go at PC number 6, and if PC number 6 don't receive the ARP request, then how PC number 6 will generate the ARP reply? This is not possible. Are you clear, everyone? Yes or no? Yes?
Yes.
Okay. Now I will tell you how and why. So guys, try to understand what this is the ICMP packet actually, okay? And this ICMP packet will hold. Why? Because at layer number 2, destination MAC is missing. So that's the reason Ethernet header is also missing here. Yes or no, everyone? In yesterday class, I told you these things. Tell me. Yes, na?
Yes, sir.
Okay. Even you guys see na at layer number 2, you guys can see na the next hop IP address is not in the ARP table. Next hop address is not present in the ARP table. So when you check here, when you check the ARP table, ARP table of PC number 5, you guys will not get 10.1. So if there is not 10.1, then definitely there will be a no MAC address also. Are you clear, everyone? So in this case, PC number 5 will generate the ARP packet. This is the ARP packet. Yes or no, everyone? This is the ARP packet. In this ARP packet, source MAC address is PC5 MAC address. Okay. Source IP address is PC5 IP address. Target MAC address is 0000. Why? Because for PC number 5, it is unknown. Right? And target IP address is 192.168.1.10. Please, this is very, very, very important. This is not 10.1, guys. Why? The reason is your ARP packet will go until, or you can say till router. This is the last point where your ARP packet can go. After router, your ARP packet will not go. Yes or no? It means your ARP packet never cross your this network. It means your ARP packet lastly go till here. Are you getting my point, everyone? Yes or no?
Yes, sir.
Yes.
Yes. So please understand, when device will generate the ARP packet, for ARP packet, destination is always default gateway.
Okay.
For ARP packet, destination is always default gateway. So it means your ARP packet will try to find out the MAC address of default gateway only, not your destination device. Are you clear, everyone? Yes or no? Tell me.
Yes.
Anyone who do not understand? Clear? So here PC number 5 is generating the ARP packet to find out the MAC address of default gateway. Clear, everyone?
Yes, sir.
Okay. So see, this packet will reach on switch forward this packet to router. Are tell me, I am opening this packet now. Everyone see very carefully. This is inbound packet. It means this packet, this router receive on gig 0/0. Yes or no? Tell me. Yes? Okay. So in this packet, what is the source IP address? PC number 5 IP address. Yes or no? Target MAC address is 008, means this is unknown, right? Target IP address is, this is the default gateway IP address. Yes or no? Everyone? Yes?
Yes.
Source MAC address means this is the PC number 5 MAC address. Yes or no? Yes. And this is the
Yes.
Ethernet header. In Ethernet header, what is the source MAC address? Source MAC address is PC number 5 MAC address and destination is FFF. It means this is the broadcast, right? And you guys, I hope already know ARP packet, ARP request always be broadcast. Yes, na everyone. Okay.
Yes.
Router receive it. This is the outbound. It means router. This is the reply, na? This is the ARP reply. Are this is the ARP reply. Are understand? Yes or no? Tell me.
Yes.
Guys, understand? I told you in previous class, na? If opcode is 01, it means this is the request. And if opcode is 02, it means this is the reply. Are you understand, na, everyone? Tell me.
Yes, sir.
What is the opcode here? 01. It means this is the ARP request. This is the ARP request. Now come on here outbound. So when you come on outbound, what is the opcode? This is the ARP reply. Understand, everyone? Anyone who do not understand? Okay. Now see, in ARP reply packet, see what is the source MAC address? What is the source MAC address? 4601. What is 4601? 4601 is the MAC address of what? Who can tell me? Come on the router. Come on this router. Everyone's here. I am writing command. So ARP. I hope it's visible to all of you. Tell me, yes or no? What is this?
Yes.
4601. Are you guys able to see here 4601?
Yes.
Yes, na?
Yes.
And this is the MAC address of
Router.
not router. This is Ethernet 0
Zero
by.
by
So it means this is the MAC address of interface Ethernet 0/0. Are you clear, everyone? Yes or no? Tell me. Clear,
Yes.
everyone? Okay. So this is the source MAC address of router interface gig 0/0. Clear now, everyone? Now, source IP address is default gateway IP address, or you can say router gig 0/0 interface IP address. Yes or no? Understand?
Yes, sir. Understand.
Target MAC address is, this is the MAC address of
PC.
PC number 1. This is the MAC address of PC number 1. Clear na? And target IP address is 192.168.1.1. It means this is the PC number 1 IP address. Anyone who do not understand till now, please let me know.
Excuse me, sir.
Yes, please.
Sir, in router, each port will have
Yes.
different
MAC address. MAC
Okay,
address.
sir. Okay, sir.
Understand, everyone? Till now, I hope you guys understand. Now, if you guys remember, in yesterday class, I told you one thing. Whenever packet will reach on the switch perform 3 tasks. What is the task? Listening, learning, forwarding. Yes or no? Yes? Same thing router will do, guys. Router, first of all, perform the listening. Whenever packet is reaching on the router's interface, router is listening the thing. After that, what router will do? After that, router will learn. After that, router will learn, guys. Understand? Tell me yes or no. Yes, na?
Yes.
After that, router will learn. See here. PC number 1, generate the ARP packet, ARP request. Yes or no? This packet reach on the router interface gig 0 by 0. Yes or no? Everyone tell me. Yes? What router is doing? Router open your ARP packet and check what is the source IP address. So what is the source IP address, guys? 192.168.1.1. This is the source IP address. Are tell me? Yes, na? Are tell me? Yes, na? What is the MAC address? C633. This is the MAC address of this PC. So this is the source IP address and this is the source MAC address in your ARP request packet, which PC number 1 is sending to router. What router will do? Router open this ARP packet and learn this one and make a entry in which table? ARP. See na, in ARP table you guys are able to see IP address is 192.168.1.1 and MAC address is 6C33. It means router learn the source address. Yes or no? Everyone tell me. Clear? So it means router listen the thing. After listen, router, what router is doing? Learning here, and after that router is forwarding. So that's the reason router is sending the ARP reply. Are you tell me yes or no? Understand na? So now it's proof. Router also performing the 3 tasks: listening, learning, and forwarding. Anyone who do not understand, please let me know. Tell me. So IP root. When I write this command, so it means this is which command, guys? Tell me. This is which command? By the help of this command, what you can check? Routing table. Yes or no? Understand na everyone? Tell me, yaar.
Yes, sir.
Now, again, this is, guys, ARP reply. Yes, na? I hope everyone now understand what ARP reply. Yes, na?
Yes.
Tell me. Okay. Now this ARP reply reach on switch. I hope now you guys will understand when PC number send the ARP request, router is not forwarding this ARP request towards this network. This is proof now, everyone. Yes or no? Yes?
Yes, sir.
Yes.
Okay. So I think in previous class I told you ARP packet always flow in the same LAN. Right na? Are you tell me?
Yes.
Yes. So again this ARP packet reach on, ARP reply packet reach on switch. Now this packet will reach on PC. Okay, what PC number 5 will do now? PC number 5 will open this ARP reply and check what is the source IP, source MAC. Yes or no? Yes. After checking source IP and source MAC, make an entry in which table? ARP table. Clear? After ARP table, what PC will do? PC will open the ICMP packet, which was hold na that time because destination MAC address was missing. Yes or no? Tell me. Yes, na? In ICMP packet, this PC put destination MAC address will be default gateway MAC address. Clear? Everyone, tell me yes or no.
Yes, sir.
Yes.
Okay. See here, this is the ICMP packet, right? Na, everyone. So at that time when I show you, there was the ICMP header, there was the IP header, but at that time Ethernet header was missing, right? Right or wrong? Right na? But now see na,
Right.
when PC learn the source MAC address from the router or default gateway, now this packet is completely encapsulated Yes or no? Source MAC address is the PC5 MAC address, and this is the MAC address of default gateway.
Yes.
It means router 0 by 0 interface MAC address. Yes or no? Everyone tell me. Clear now?
Yes, sir.
Yes, sir.
Are you guys, when you guys are seeing this packet, you guys see one thing. What is the destination IP address? Sorry, leave it. What is the source IP address? 192.168.1.1.
66.
This is the PC number 5 IP address. Yes or no? Yes. What is this? This is the source MAC address, right? And this is the MAC address of
PC5.
PC5. Okay. Are tell me yes or no? Yes. You know, na, this is the IP header.
Yes.
And IP header works at layer number 3, right? So in
Yes.
in layer number 3 or in IP header, you guys will get the information about the IP address. Yes or no? Yes. And this is called Ethernet header. Ethernet header works at layer number 2, right? And at layer number 2, you guys will get the information about MAC address. Are tell me yes or no? Yes, na?
Yes.
Whatever the source MAC address here, whatever the source MAC address here, sorry, source IP address here, and for that IP address, you guys will get the MAC address. Yes or no? Yes, na?
Yes.
But here, what is the destination IP address? 10.1.
One.
But what is the destination MAC address? 4601. It means IP address is different and MAC address is different. Yes or no?
Yes.
Tell me. Yes, na? So basically, interview. I am telling you this one because interviewer will try to confuse you. So please don't confuse. That's the reason I am telling you again and again. If this type of scenario, it means definitely this is our default gateway MAC address. Are clear na everyone? Interviewer will ask कि generally when packet is encapsulated, whatever the source IP address at layer number 3, so that IP address, MAC address is present at the Ethernet header. But this is not always correct. Sometimes you will get source IP, sorry, destination IP address is different and MAC address is, destination MAC address is different. It means destination MAC address is of default gateway, not this IP MAC address. Getting my point, everyone? Are you tell me?
Sir.
So this is the ICMP packet. Now this ICMP packet is completely encapsulated. Yes or no, everyone? At every layer,
Yes.
right? Everyone, are you tell me? Yes or no? Yes,
Yes.
na? That time when I write the ping command, that time this packet was hold because at layer number 2, destination MAC address was missing. Now MAC address is fulfilled. So now this packet is completely encapsulated.
Yes.
Now this PC number 5, forward this ICMP packet. See, this ICMP packet will reach on switch. Switch forward this packet to router. Are you getting my point? Yes or no? Tell me.
Yes.
Yes. So see, yes, Unicast. Now see, when this ICMP packet reach on router, when this ICMP packet reach on router, this packet is drop. What is happening? This packet is, guys, drop. But actually we are not telling drop. We can say this packet is hold. Are this packet is hold. The reason is, try to understand the reason. Oh, I have opened this packet. This is the inbound packet. Yes or no? It means this packet router receive. Yes or no? Are you tell me? Are you tell me yes or no? Yes, na? So
Yes.
see, this is the ICMP. This is the IP. Source IP address is this one. Destination IP address is this one. Are you tell me yes or no? Yes.
Yes.
Now, and this is the Ethernet header. So ignore this one because a router only check the layer number 3 information. Yes or no? Yes. Are you tell me? Yes, na? Now, come on outbound. When you come in outbound package, see na, one thing is missing. ICMP header is there. IP header is there. But where is Ethernet header? It is missing. Reason? Reason is, please remember this one. When this packet, ICMP packet reach on router, okay? So this packet, this PC is sending the packet to its default gateway, right? And this is the default gateway. So when this ICMP packet will reach, and this is the responsibility of this router to perform some modification in this packet, and for after that this router will forward this packet towards this network. Getting my point, everyone? Again, I am telling. First time when you write ping command, guys, first of all, this PC generate the ARP packet. Yes or no? Right? And this is the responsibility of ARP to find out the MAC address of this interface and inform this PC. Yes or no? Yes?
Yes.
So this is the function of ARP. Now come on ICMP. Guys, ICMP is the unicast. So ICMP can go from one network to another. There is no problem. But ARP is the broadcast. So ARP will not go from one network to another. Clear na? I hope you guys understand this one. Right na? Are tell me.
Yes.
Guys. Okay. Now, this ICMP packet will reach on this PC. Sorry, this router. Okay. This router receive the inbound packet. Everything is same. But after that, I told you, na, router performs some modification in this ICMP packet. Then after router will forward this ICMP packet towards this PC. Yes or no? Tell me. Guys,
Yes.
understand? So when this
Yes.
router open your ICMP packet, when this router open your ICMP packet, this is the ICMP packet this router receive, right? This router check. First of all, this router will check what is the source IP address. What is the source IP address, guys? What is the source IP address? This one, na? 192.168.1.1. What is the destination IP address? 10.1. It's clear to all of you? Everyone, anyone who do not understand till now? It's clear? Okay. Now, open this one. When you open this one, what is the source IP address? What is the source IP address?
Same
10,
one as
192.168.1.1. And what is the destination IP address? 10.1. Now, this router open its ARP table and try to find out, do I have MAC address of 10.0.0.1? Getting my point, everyone? Because this router modify your packet, na? Then after this router will forward this packet towards this network. Getting my point, everyone? Tell me. So this router will check what is the destination IP address. Destination IP address is 10.0.0.1, but and router will try to check the MAC address of this IP address in which table? ARP table. Are you getting my point, everyone? See, when router will check, so ARP. So do you have 10.0.0.1 MAC address here, guys?
No.
What is this?
Incomplete.
Incomplete.
Hence, this router do not have 10.0.0.1. Are you getting my point, everyone? Yes or no?
Yes.
This router received 10.0.0.1 as a destination IP address. So that's the reason this IP address is visible in your ARP table. But still this router do not have MAC address of 10.1. Are you getting my point, everyone? So that's the reason what you guys are seeing here, incomplete. Clear? Are you understand, everyone?
Yes. Yes.
So this ICMP packet was hold here. Why? Because this router is not able to complete encapsulate this ICMP packet, right? Because router wants to perform some changes in this packet, but router do not have 10.0.0.1 MAC address. So that's the reason this packet is incomplete. Yes or no? So that's the reason ICMP packet was hold here. Clear? Anyone who do not understand? Now this is the responsibility of router to find out the 10.0.0.1 MAC address. Yes or no? Yes. This is the responsibility of router to find out the 10.0.0.1 MAC address. Then after router will able to encapsulate this ICMP packet. Yes or no? Yes, na everyone? Tell me.
Yes.
Yes. So to find out the MAC address of 10.0.0.1, router will generate which packet, guys? ARP packet. Which packet? ARP
Yeah.
packet. See, na, there is one more packet. When I open this packet, see, what is this? This is the ARP packet. Are you getting my point, everyone? Yes or no? Yes?
Yes.
If you guys understand, I think I told you in the previous class also, router do not forward the ARP packet from one network to another network because this is the broadcast packet. Yes or no?
Yes.
Yes, sir.
After that, I told you one more concept, but router can generate the broadcast packet like ARP packet. Yes or no? I told you these
Yes.
two things. Don't be confused. Yes, na everyone? And I hope you guys
Yes.
are able to see here. Right? Everyone? Tell me. This PC generate the ARP request packet and this is the broadcast packet. This packet will reach on the router, but router do not forward this packet here. This is the concept number 1. Yes or no? Yes.
Yes.
And in concept number 2, this router wants the IP address of MAC address of 10.0.0.1. Then after this router will completely encapsulate the ICMP packet which is hold here, right? So in this case, router is generating the ARP packet. And this is the concept number 2. Anyone who do not understand the thing? Guys, I am telling you complete from the scratch level. And I
Yeah.
hope you guys are feeling these things, right?
Yes.
I'm not getting anything, guys. Why you
Yes.
guys are...
Yeah, honest.
I am trying my best to deliver the things from the complete scratch level. So you guys have complete understanding on it.
Yes. Sir.
Nabil, are you happy? You are telling again and again, sir, packet flow, packet flow, packet flow. I hope you are enjoying.
It looks like more complicated than heart surgery.
Okay, so Nabil asked
Okay.
question. Okay. But yes, this is complicated, but try to understand the way actually I'm trying to deliver the thing. Maybe it will help you to understand from very scratch level. Sir, if the router perform all those process, then the router send a broadcast. Yes, now will actually router send the or generate the broadcast packet. The rule is router never forward the broadcast packet from one network to another. But yes, router can generate the broadcast packet like ARP request. See na here right now, router is generating the ARP request. Yes or no? Guys, what is the opcode value? 0x0001. It means this is the ARP request. Who is generating? Source IP is 10.10. It means this is the source IP address. Router is generating this ARP request. Yes or no? Yes.
Yes.
And source MAC address is this one. It means this is the MAC address of this interface. Are you getting my point, everyone? Yes or no? Yes. And target MAC address is 0000. It means this router don't know the MAC address of target IP, that is 10.1. So it means you can say target IP MAC address is unknown for this router. So that's the reason target MAC is 000. Clear? Everyone, tell me. What is the destination MAC address? FFF. And it proves this is the broadcast message. Nabil, understand? Any doubt now? We have redirected now the ICMP with the help of ARP cache. I'm not getting actually what you are trying to say. See, why are you mixing the thing ARP kaise or proxy ARP? These are the different concept. Okay, so don't mix the thing. ARP table. See, I show you na the ARP table of this router. See na, this is the ARP table of this router. Do you have the 10.1 MAC address? No, we do not have. This is incomplete. And by the help of this ARP request, router is trying to find the MAC address of 10.1. Right, everyone? I told you these things. Tell me.
Yes, sir.
Yes? Okay.
Yes.
So this is the ARP request. Who is generating, guys? Router is generating. This packet will reach on switch. What switch will do? Forward this to PC. Tell me. Understand?
Yes.
This is the inbound packet. This PC receive. Yes or no? So in this packet, what is the source IP address? 10.10. What is the source MAC address? 4602. What PC will do? PC first of all perform the learning task. In learning task, what PC will do? PC learn the source IP address and source MAC address and make the entry in which table? ARP table. Yes or no? Yes?
Yes.
What is the command? ARP A.
Right.
So this PC make entry 10.10 IP address and this is the MAC address of this IP. So it means this PC perform the learning task. Understand everyone? Yes or no? So this PC perform the learning task. Clear now? Anyone? Any doubt till now? Okay. After that, what PC will do, guys? PC will generate, and this is the opcode value 1. It means this is the request. Right? This is the ARP request. Now PC will generate the ARP reply. See now, this is the outbound. Outbound means this is the request or reply. This is the reply. And in this reply, what is the source IP address? 10.1. And what is the source MAC address? This is the PC number 6 MAC address. Yes or no? Yes.
Yes.
And what is the target IP address? 10.10. It means this is the default gateway, na? This PC generate the ARP reply to its default gateway because ARP packet never cross here. Yes or no? Yes, na?
Yes.
So this PC generate the ARP reply for the default gateway. So target IP address is 10.10. And what is the target MAC address? And this is the MAC address of gig 0 by 1. This interface MAC address. So this is the ARP reply, and this ARP reply is unicast or broadcast? Unicast. Because everything is here. Everything, PC know everything. So that's the reason this is the unicast. Everyone understand? Yes or no?
Yes, sir.
Yes.
Okay. So and PC already learned the MAC address, right? This PC generate the ARP reply. So this ARP reply will reach on switch. Switch forward this to router. Switch forward this to router. What router will do? Router learn the source MAC address and make the entry in which table? ARP table. Yes or no? Everyone tell me. At that time when I write this command, at that time 10.1 MAC address was incomplete. Yes or no? Yes, na?
Yes, sir.
Tell me yes or no. That time when I run this command, that time router don't know what is the MAC address of 10.1. So that's the reason it is incomplete. So that's the reason router generate the ARP packet to find out the 10.1 MAC address. Now PC generate the ARP reply and router receive the ARP reply. It means now router already know what is the MAC address of 10.1. Yes or no? Yes, na?
Yes, sir.
Tell me. So when I write the same command here, see here, router now know what is the MAC address of 10.1. Anyone who do not understand, let me know. Nabil, stand. Saeed, Ibn, Lakshman, Rahul, Sankar, Tanush. Why you guys are so silent?
Sir, what is making that router to send broadcast ARP?
What is?
No, sir, what is making to generate broadcast message to
See, actually,
that?
router can generate the broadcast packet in the scenario when router don't know what is the MAC address of destination device in the same LAN.
Oh, okay, sir.
Okay. So now router know the 10.0.0.1 MAC address. Now, guys, when, if you guys remember, when this PC generate the ICMP packet, this packet was reach here. And that time this router hold that packet. Why? Because this router don't know what is the MAC address of 10.1. Yes or no? Everyone tell me. Yes?
Yes, sir.
Tell me yes or no. Yes, na?
Yes.
Guys. Yes, na? Now this router already know what is the MAC address of 10.1. So it means now this router put the MAC address of 10.1 in the ICMP packet and forward this ICMP packet towards here. Yes or no? Everyone, tell me.
Yes.
Yes, na?
Yes.
Guys.
Yes.
Okay. Arey yaar, what is happening here? This is the bug in the packet tracer. This is a different packet, I think. Yes. Wait. This is the ICMP packet, I think. Inbound. Are you guys able to see na? Are see na?
Yes.
This is the
Yes, you can see.
ICMP. This is the IP header. Everything is fine. Yes or no? Source IP is 190.168.1.1. Destination is 10.1. This one. Yes, na everyone? Yes or no? Tell me. Guys, what is the
Yes.
source MAC address? Source MAC address is PC number 5 MAC address. And destination MAC address is gig 0 by 0 MAC address. It means
0.
default gateway MAC address. Are clear na everyone? Yes or no? Yes?
Yeah. Yes.
Now this packet is on where? Router. So this is the inbound. It means this router received this packet. Now come on outbound. So when you come on outbound, now see what is the source IP address? 192.168.1.1. It means this is the PC number 5 IP address. Destination is 6, right? PC number 6. Now, but what is the source MAC address? Source MAC address
0
is
by 1.
4602. It means this is the MAC address of gig 0
0 by
by
1 difference.
this is this interface MAC address. Getting my point, everyone? Yes or no? Yes, na? Now, what is
Yes.
the destination MAC address?
PC 6
This
MAC
is the
address.
MAC address of 10.1. 10.1. Because now this router already know what is the MAC address of 10.1. And this router already learn this address in its ARP table. Yes or no? Yes, na? Everyone? Yes. So this is called 10.1 MAC address. Now what router will do? This is the ICMP packet. This is the unicast, right? So this router will forward this packet to switch forward to PC.
PC 6.
And PC receive this packet inbound, right? PC change something. What PC change? See now, when this PC received this packet, what is the source IP address? This one. Destination is this one. Source MAC is see now, source MAC is this one. It means this is the gig 0 by 1 MAC address. This one MAC address. And destination MAC address is 10.1 MAC address. Yes or no? 10.1 MAC address. Yes or no? Yes. And this is called ICMP request or reply?
Request.
Request. Now, PC number 6 will generate the ICMP reply. Yes or no? Yes, na?
Yes.
Tell me. I told you in previous class, if you guys remember, what is the type field? 0x08. It means this is the request. And when you get 0x00, it means this is the reply. See na? What is the type field? 0x00. It means this is the reply. Are clear na everyone? See na PC, what
Yes.
PC number 6 is changing? PC number 6 is changing. What is the source MAC address? This is the PC number 6 MAC address. Yes or no? Are tell me. And destination MAC address is default gateway MAC address.
Yes.
It means 10.10 MAC address. Are clear everyone? Source IP is 10.1 and destination is same 192.168.1.1. Anyone who do not understand? And rest are same. Packet reach on, switch forward to where? Router. What router will do? Router first of all open this packet and check what is the destination IP address. What is the destination IP address, guys? 192.168.1.1. What is the destination IP address? 192.168.1.1. This router open its which table? So IP root routing table. And see na, router will find 192.168.1.0 is directly connected on which interface?
0 by
This
0.
network is directly connected on 0 by 0. So router will forward this packet by 0 by 0. Clear everyone? Yes or no? 0 by 0. So router will forward this packet by 0 by 0. Reach on, switch forward to PC. Anyone who do not understand everything? And this PC also maintain the which table, guys? ARP.
Yes.
It's called packet flow in the different subnet. Clear everyone? Tell me. Understand? Nabil?
Yes.
Yes.
I hope now you guys understand the packet flow in the same subnet, packet flow in the different subnet. Clear?
Yes.
Okay. Okay. We have around 15 minutes. So what I am trying to show you. Next topic is guys IPv6. But yes, I am telling you this is something boring topic. But yes, I can explain you something about the IPv6. Maybe try to understand the thing. So IPv6, IPv4. Currently, maximum case we are using the IPv4. Okay, na? But yes, IPv6 is our future. So maybe in coming time we are going to use IPv6 many more. So IPv6 is works at which layer, guys? Same layer. Which layer? Network layer. Which layer, guys? Network layer. IPv6 was designed by IETF. IETF stands for Internet Engineering Task Force. Okay, in 1998. Are you getting my point, everyone? In 1998. Okay, na? And the reason is because you know na, when IPv4 was discovered, at that time we do not think the population of world will go till high and the demand of internet will go till the next level. We don't think like this. But see na, nowadays, you know na, for in every family there are 5, 6, 7, 10 devices which we are using the IP address like this. Yes or no? Yes na. So nowadays the usage of IP address is quite high, right? And the IP address cannot resolve our problem. So that's the reason to solve these type of problem on we have a concept of IPv6, and IPv6 was discovered in 1998 by IETF. Are clear everyone? Understand? And this is the latest version of the IP address. Are clear now everyone?
Yes.
The older version IPv4 provides around 4.3 billion unique IP address. But you know na, the population of world is quite high. But the growth of the internet and more device coming online, these address running out. So that's the reason we need the different IP address that is called IPv6. Are clear everyone? IPv6 was a large number of IP address, around 4 340 undecillion. Undecillion. Guys, I also don't know what is undecillion, but I think I already written something about the undecillion. Undecillion means 36 0. Undecillion means 340 means, see na, this is the number 36 0. Are you getting my point, everyone?
Yes.
So basically IPv6 provides this type, this vast number of IP address. Okay. Now, next thing is, if you guys remember, what is the size of IPv4, guys? 32-bit, right? Everyone. What is the size of IPv6? 128-bit. IPv4 is written in how many group? 10.0.0.1. How many group? 1, 2, 3, 4. Right? Everyone. And in each group, how many bit? 8, 8, 8, 8. So 8 into 4, 32-bit. Yes or no? Are you tell me?
Yes.
Right, na? But in IPv6, how many group? 8 group. How many group? 8 group. See na? This is the example. 8 group. So that's the reason it is much longer than IP address. Are you understand, everyone? Clear na?
Yes.
Are you tell me? Okay. IPv6 has how many block? 8 block. Okay na? And each block is known as, sometimes in some book you guys will get segment, or in some book you guys will get hexstate. Clear na? Understand? And each block consisting 4 hexadecimal digit, and each one is separated by colon. But in case of IP address, we are separating by dot, na, everyone? Yes or no? But in case of IPv6, we are separating by column. Clear, everyone? Understand?
Yes.
And you guys need to remember this one, the smallest value of the entire block is 0000. For example, this is the IPv6 address. So see na, here what is the value in this column or in this block? 0000, and this is called smallest digit or smallest value. I understand, everyone? And see this MAC address. In this MAC address, in this column, what is the value? FFFF. It means this is the highest. This is the highest. Guys, IPv4 address is written in the decimal, but it is written in the hexadecimal. So I hope you guys have something idea about the hexadecimal. In hexadecimal, we are writing na 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, A, B, C, D, E, F. Right na, everyone? Yes or no?
Yes.
Yes na? Okay. So that is the maximum number. FFFFF. Okay. Now, if anyone asks you what is the range, for example, in IPv4, what is the range of in each octet? 02255, right? This is the maximum number in IPv4, right? Na, everyone? But in case of IPv6, what is the range? 02 FFFF. Clear? In IPv4, there is a concept of class A, class B, class C, class D, class E, right? But in case of IPv6, there is no such type of concept. Clear, everyone? IPv6 use class, yes, in IPv6 or in IPv4 we are using the CIDR concept, but yes, in IPv6 also we are using the CIDR concept. Understand, everyone? The first 64-bit, what is the size of IPv6, guys? 128-bit. Similarly, in case of IPv4, what is the size? 32-bit. And you know na, I told you, if you guys remember, IP address is divided into 2 parts. One is network part and second one is host part. Right or wrong? Right na? Tell me.
Yes.
So in IPv4 by default, it is called 16-bit is called network and 16-bit is called host. Similarly, in case of IPv6, 64-bit is called network and rest 64 is called host. So 64, how much? 128. Right? So first 64-bit is known as which one? Network. And last 64 is known as host.
Yes.
Understand, everyone?
Yes.
To create a network, all devices within the same network must share the same network ID. Same in case of IPv4. For example, this is the switch PC number 2. If you configure 10.0.0.1, here you must need to configure not 10.0.0.2. It means all the network belongs to 10th network. Yes or no? Everyone.
Yes.
Yes. Similarly, in case of IPv6, if you are assigning the IP address, it means this should be this will share the same network ID. While each device on the network must have the unique host ID. Yes, guys, try to understand these 2 points. For example, think like this. Here I assign 10.0.0.1. Here I assign 10.0.0.2. Tell me, what is the network ID? 10.0.0.0. Yes or no? Everyone, tell me. Yes?
Yes.
What is the host ID? Host ID is same or different? Different. On PC number 1, I configure 10.1 and here I configure 10.2. Yes or no? Tell me.
Yes.
Yes, na? So try to understand here, network ID is same. Both PC share the same network. But yes, to separate the thing, we have a different host ID. If host ID will be same, then how can you identify a device on a network? It is not possible. Tell me yes or no? Yes, na?
Yes.
So to identify a device or to segregate the device, we have a concept of host ID. Same case in similarly in case of IPv6. In IPv6, network ID is same, but to segregate the thing, we have a concept of unique host ID. IPv6 does not use the broadcast address. This is also very important. In IPv4, we have a concept of broadcast, but in case of IPv6, there is no concept of broadcast. Understand? It use yes. In IPv6, we have a concept of multicast, unicast, and multicast. IPv6 address categorized into the different type based on their purpose and scope of communication. The primary category is unicast and multicast. I told you, na, in IPv4, there is a concept of unicast, multicast, and broadcast. But in case of IPv6, only unicast and multicast. Unicast and multicast. Unicast means unicast address are used to identify a single unique interface, right? Now that is called unicast. If I am writing 10.0.0.1, it means this is the unicast, and by the help of this IP address, we can define now this IP address you can define only on any one interface. Yes or no? Yes.
Yes.
And for example, if I am running 224.0.0.5, this is the multicast. So it means, let's suppose this IP address are using generally by routing protocol OSPF. For example, this is the router, this is the router, this is the router. On the router, let's suppose I configure OSPF. It means all the three router understand this one. That is called multicast. Are you getting my point, everyone? So unicast means only one device you can assign this one, and multicast means multiple device can understand the multicast address. Are you clear, everyone? Now again, unicast is also divided into some category. See na, unicast address are further divided into three parts. First is global unicast. Second one is link local address, and third one is unique local address. Global unicast address. This is used for the communication over the global internet. So think like this, don't confuse. Global unicast address is same as a public address, public IP address. You know na public IP address, everyone?
Yes. This is private address.
This is routable on the internet, right? This IP address is routable on the internet, and this is unique. And you have to purchase it. This is not free of cost. Yes or no? Yes, na? Now, link local address. Link local address. Link local address, you can understand like the APIPA address. If you guys remember, I told you APIPA. Right now, for example, this is the Windows device. If you do not assign any IP address manually, and this device is not getting the IP address by DHCP also, then by default address will be APIPA address. Understand, na? Range will be 169 to something. You guys can check. Understand? This is called APIPA, and this is also reserved IP address. So link local address is same. Link local address is like a APIPA address. Are you clear, everyone? And this address is routable only and only inside the LAN, not over the internet. Clear, everyone? Tell me.
Yes.
That is called link local address. And last one is unique local address, ULA. ULA, you can understand like a private IP address. And this is routable only and only in the LAN network. Clear, everyone?
Yes.
Tell me. Understand? Next one is, guys, the multicast address. Multicast address, this address are used to send the packet to the multiple device. I told you, because on multicast address, the device which can understand the multicast address, the whole device can understand that IP address. Understand? For example, this is the router, this is the router, this is the router. For example, on all the three router, if you configure the OSPF, it means all the three router can understand the multicast address. And this is the fourth router. If I do not configure any protocol, then this router never understand the multicast address. Are you getting my point? Understand? That is called multicast address. So there is a rule. If any device can only understand the multicast address, then that device must be the part of multicast group. If your router is not the part of multicast group, then router cannot understand your multicast address. This is the rule. Understand? Everyone. So when you configure the protocol like OSPF or EIGRP, so generally what is happening? Your router will part of the multicast group, or your router will join the multicast group. It means now your router can understand the multicast address. Getting my point, everyone? In IPv4, a specified address range where designed over the each type of address IP defined. Yes, this is the range, guys. You know, na, in IPv4 there is also class A, class B, class C range type, right? Na? So this is the global unicast, link local, and site local, and this is the range. This is the range, this is the range, and this is the range. Okay. If you want, you guys can remember these things. Clear, everyone? Tell me. This is there are three types of address I told you, na? Global unicast, link, local address, and ULA. This is the public, this is the APIPA, and this is the private. Yes or no? And for these three type of address, there is a range. There is a range. This is the range of global, the public IP address. This is the range of APIPA, and this is the range of private. Are you clear, everyone? Yes or no? Tell me. One more thing, this is also very important. This is the IP address, guys. This is the IPv6 address. Think, na, as a network engineer, if anyone tell you to configure this address on any 5 device, you guys will tired, na, to configure this long address. Yes or no? Are you tell me? Yes. We will tired. But yes, guys, we can sort this address. How? See, now this is the address and this is the sort form of this one. This is the sort form of this one. How I sort? See here. What I written here, guys? FC00 dual column 1. Try to understand what I did. FC00. This is same. Everyone. Same? Yes or no? Yes? So see here. Here in this block, complete 0, complete 0, complete 0, complete. It means here till here to here, 0 is completely repeating in each block. Yes or no? Tell me. So when 0 will repeat, na, you can write dual column instead of writing 0. Getting my point, everyone? So here I write 0, dual column. Okay. And the last one is 0001. So instead of 001, you can simply write 1. So this is the shortcut form. Understand, everyone? Tell me.
Yes, sir.
In place of repeated 0, we can write dual column. And 001, we can write simply 1. Now, there is one more question here. If we have a different network, like let's suppose if we have this one, then see na, FC00. Everyone see here. FC00, same is there. Here, see na, here to here, complete 00 repeating. So I write here dual column, again 0001. So I write 1, again 000 repeating. So write dual column and again I write 1. Getting my point, everyone? But this is not correct. Because there is a rule in a single IP address, you cannot use dual column 2 times. You cannot use dual column 2 times. So you have to use only 1 time, guys. You have to use only 1 time. So either you can write like this or either you can write like this. Are you getting my point, everyone? Yes or no? So either you can use the dual column here or either you can use dual column here. Guys, tell me, understand? Yes or no?
Yes, sir.
So this is the rule in a single IP address. Dual column we cannot use 2 times. And this is the difference between IPv4 and IPv6. IPv4 size is 32-bit. IPv6 size is 128-bit. IPv4 is written in dotted decimal, right? Na? But in
Yes.
IPv6 is hexadecimal. You guys will get A, B, C, D, E, F. IPv4 at size is around 4 billion, but IPv6 is 130 unidecillion and support the broadcast. IPv4 support the broadcast. IPv6 do not support the broadcast. IPv4 is simple and handy to use, but IPv6 is more complex. Understand, everyone? So this is the difference between IPv4 and IPv6. Clear, everyone? Tell me.
Yes.
Tell me yes. Yes, no. In IPv6, there is one more thing. What do you mean by anycast address? What do you mean by anycast address? See here what I write. An anycast address in IPv6 is a special type of address that allow multiple device or node to share the same address. It means there is a one single IP address and that IP address will share by, for example, in IPv4 there is one concept, one protocol. This is the CCNP concept, guys. In CCNP, basically we are seeing these things, HSRP. Okay, for example, this is the router, and generally we configure the one IP address. Getting my point? And this router also understands this IP address, and this router also understands this IP address. Getting my point? So that is called in HSRP. Generally we are doing, but in case of IPv6, that is called anycast address. This is called anycast address. The key idea is that data sent from the anycast address is delivered to the nearest in term of the routing distant node that hold that address. For example, this is the router and this is the router, and both router use the anycast. Getting my point? And let's suppose this router is nearest to the source. So this router use the anycast address and forward this packet through this one. So this is the basically use of anycast address. I already written one example. Imagine you have a website with server in the New York, London, and Tokyo. Clear? You can assign the same anycast address to all the server, which is present in New York as well as Tokyo. When user from the New York access your website, their request is routed to the nearest server that is called New York. Are you getting my point? And if user is accessing the server, and that whole the traffic will go through the Tokyo, and this is possible because of the anycast. Because on New York's server and Tokyo server, we configure the same anycast address. Getting my point, everyone? So basically, this is the use of anycast address. Clear, everyone? Tell me.
Yes.
Now I already mentioned one thing here, guys. You guys can do the same thing in your packet tracer. How we can configure the IPv6 on the router. See here, I choose 2 router here. On this router, I am going to configure this one. On this router, I am going to configure this IP address. Getting my point? Everyone tell me yes or no. Understand?
Yes.
See, what is the command? The first command is, I am on router number 1. I write interface fast Ethernet 0x0. I write IPv6 address. Then I write this one. Slash, and after that you have to write the subnet mask. Are you clear, everyone? Yes or no? Yes, na? So this is the way we can configure. And after that you have to write no shutdown command. Same here on R2. Same here on R2. Clear, everyone? Are you tell me? Yes. Why you guys are so silent?
Pinging, we need to type IPv6 also there.
Sorry. Yes, IPv6 you have to mention. First, start with the IPv6. And now see, when you try to ping from R1 and R2, R1 to R2, what is the command? Ping. Then after you have to write IPv6, and then you have to write the IP address. Are you getting my point? Understand, everyone?
Yes.
Ping IPv6, then write the address. This is the command by which you can ping from R1 to R2. And I told you, na, there is one command by which you can check all the IP address configured. So IP interface brief. Are tell me. Understand na? I told you na in IPv4. Right now I told you. So IP interface brief. In case of IPv6, command is same. Only you have to write the IPv6. In case of instead of IP, you have to write IPv6. When you check the routing table in case of IPv4, what the command you are writing? So IP route. Yes or no? Right na?
Yes.
But in case of IPv6, what you have to write? IP. So IPv6 route. So IPv6 route. Clear, everyone? Are tell me. Understand? If you want to check any interface in a very detailed way, what you command you guys can write? So IPv6 interface, let's suppose fast is 0x0. I want to check fast is 0x0 in a detailed way. So this is the command. So see now fast is 0x0 is up, LAN protocol is up. This is the MAC address. Everything if you want, you guys can get in the detailed way. Getting my point, everyone? Tell me. Understand? And these are the basic thing. How can you check the IP address in Windows device, Mac device, or Linux? Okay, na? So I already written. You guys can read. You guys will understand. Windows, you know, nowadays Windows. This is the frequent, or you can say maximum number of users are using the Windows device. So if I want to check the IP address, so what is the command, guys? IP config, right? Na? Are IP config? Na? We are writing the IP config command. Yes or no?
Yes, sir.
I have a Windows device. I am writing na IP. Understand, everyone? Are tell me. This is the Wi-Fi I am using. This is the IPv4. This IPv4 I am using. So basically, this is the command in the Windows to check the IP address. Similarly, in the Mac, there is a different command. There is a different command.
Yep.
IP config same. And if in a Mac, if you want to check IP address on particular interface, so this is the command. In Linux, there is a different command. Okay. So basically, these are the things, guys. This is all about the IPv6. I will share these things with you guys. Okay. Everyone. So I hope guys you guys understand the packet flow in different subnet and some introduction about the IPv6. Okay, everyone.